So for the length is equal to, we're given with 75. Multiply this to 1000 to convert because this is in meter. So we have now 75,000 mm. For the area, of course, given, which is 300 mm squared, and we have our E, modulus of elasticity, which is 200,000 megapascal. And if we try to compute now for the deformation 1 due to its own weight, or this is our elongation due to its own weight, so we simply have to substitute to the formula PL all over AE. So we have identified our P, which is 343,465.3825 times 75,000 all over 300, the cross-sectional area, times E, which is 200,000. And if we try to simplify this one, we have 4.33 mm. And for the second, for elongation due to the applied load, we are given with an applied load at the bottom of the steel, which is 20 kilonewton. And based on our figure, we have this steel, we have a applied load at the bottom, which is 20 kilonewton. And basically, this total original length is 150 mm, 150 meters rather, 150 meters. And due to the applied load, 20 kilonewton, we have elongation 2. And if we try to get the value for elongation due to the applied load, PL all over AE, our P is 20 kilonewton, so we simply have to substitute 20 kilonewton or 20,000 newton. Our L is 150 meters, convert to mm, so we get 150,000 all over the area, which is 300 times E, which is 200,000. And this gives us a value of 50 mm. So this one, to get now the total elongation, we have equal to elongation 1 plus elongation 2. So it gives us 4.33 plus 50, so we have here 54.33 mm. So this is the total elongation. Problem number 2. A steel tire 10 mm thick, 80 mm wide, and 1,500 mm inside diameter is heated and shrunk onto a steel wheel 1,500.5 mm in diameter. If the coefficient of static friction is 0.3, what torque is required to twist the tire relative to the wheel? Neglect the deformation of the wheel. Use E, which is equal to 200 gigapascal. So for our solution, of course, we have deformation is equal to PL all over AE. So our deformation or elongation is equivalent to, we have an inside and outside diameter, so we have pi times this of O, which is 1,500.5, subtract to the inside diameter, which is 1,500. So it gives us 0.5 pi mm. So our P, of course, is equal to our T. And our L, we are given with 1,500 pi. And our A, the area, is equivalent to 10 times 80. The thickness of the steel tire is 10 mm thick, and the wideness is 80 mm. So this gives us 800 mm squared. And of course, we are given with our A, which is 200,000 1000 megapascal. So we simply have to substitute to our formula so that we can get the value for our T, which is our P. So 0.5 pi is equal to T times 1500 pi over 800 times 200,000. And this gives us T, which is equivalent to 553,333.33 Newton. And from our equation, that bursting force is equal to 2 times the resisting force T. So this is equal to internal pressure times the area, which is 1500 multiplied to the wideness, which is 80, equal to 2 times T, which is 53,333.33. And our internal pressure is equal to 0.8889 megapascal. Now to compute for the total normal force, N, which is equivalent to internal pressure times the contact area between the tire and the wheel. So therefore, this is equal to 0.889 times pi times 1500.5 times the thickness, which is times the wideness of, which is equivalent to 80. So this gives us the normal force equal to 335,214.92 Newton. And for the friction resistance, our F, so that is mu times N. Our mu is given, which is 0.30. Multiply this one to our computed normal force, which is 335,240.92, and it gives us a value of 100,564.48 Newton, or this is 100.56 kilonewton. And for the torque, to compute for the torque, this is frictional resistance times 1/2 of the diameter of the wheel. So therefore, if we try to substitute, we have our computed friction resistance, which is 100.56 multiplied to 1/2 of our diameter of the wheel in meters. So we have converted our value of 1500.5. So this gives us 0.75025. So if we try to substitute, if we try to simplify this one, we have 75.44 kilonewton meter. Problem number 3, an aluminum bar having a cross-sectional area of 0.5 inches square carries an axial load applied at the position as shown in the figure. Compute the total change in length of the bar if E is equal to 10 times 10 to the 6th psi. Assume the bar is suitably braced to prevent lateral buckling. So we are given with our figure with the applied load. So we're going to get our internal forces P1, P2, and P3. So let's section our bar. So if we try to section, so we have here our force, which is 6,000. So therefore we have also, and we have this internal force, which is our P1, which is 6,000 pounds. And this is in tension. So if we try to the second bar, if we try to section that one, so we have here 6,000, then we have here 7,000. So therefore, we have an compressive force, which is our P2. This is equivalent to 1,000 pounds, and this is in compression. The third bar, if we try to section, so we have here 6,000, we have 7,000, we have here 5,000, so if we try to, we have here another 5,000. So if we try to identify the internal force, we have the value of P sub 3, which is equivalent to make this balance, so this is in tension, so we have 4,000 pounds, and this is in tension. So we have now identified our P1, P2, and P3. So therefore, we can have our deformation, which is the summation of the deformation for each bar. And of course, the formula is deformation PL over E. So we simply have to have deformation is equal to deformation 1 minus deformation 2. Deformation, this is positive 1. Deformation 1 is positive. Then the second one is going to that side is negative. And this is also plus. So we have here deformation 3. So if I try to simply substitute the values for using this equation, so we simply have 6,000 times 3 times 12. Since this is in feet, convert this one to inches. All over 0.5 times 10 times 10 to the 6th. Then minus 1,000. We simply have to substitute our P. We have 1,000 times 5 times 12 all over 0.5 times 10 times 10 to the 6th. And plus, we have 4,000 times 4 times 12 all over 0.5 times 10 times 10 to the 6th. And our deformation now, the lengthening or the elongation is equal to 0.0696 inches.